Good evening to everyone. In my last class, I just come across with half wave rectifier. That means in AC waveform, either positive or negative half cycles can be rectified into a DC pulse. Okay, into a DC pulse. Okay. So in your last video, instead of at terminal A, instead of at a terminal A, if you place the diode at terminal B, kindly check what will be your expected output. Okay, kindly check your expected output if you place the diode at B. Okay. So for today's class, we go for full wave rectifier. That means full wave rectifier means both positive and negative half cycles should be rectified. Both positive and negative half cycles should be rectified. So we are going for full wave rectifier. So again, we are not modifying our input. Our input is same. It has both positive and negative half cycles. Here you are saying one word, that means both positive and negative half cycles will be rectified. Both positive and negative half cycles will be rectified. That means either this way, or this way we are going to see. So both are possible. Rectify means both will be converted, whether we are coming to this side or this side, we are going to be check. Okay. So as you know that it is just extension of your half wave rectifier, we are not complicating anything else. Okay. So kindly observe. In half wave rectifier, we seen one diode will restrict, one diode will stick to the one half cycle, that means positive half cycle. Similar fashion, if you place one more diode which can works for negative half cycle, the problem will be solved. That means we are modifying our circuit in such a way. This is our primary side. We are not have any difference here. We just take our 220 volts, and here we are taking the transformer secondary. Kindly observe, I need to place a diode in positive as well as negative half cycles rectification. So I am just two diodes. That means these two will be comes under one terminal. To get ground potential, I am considering this as my ground potential wire. So here to this common terminal, I am placing my load resistance. So the circuit is very simple. Very simple. If you observe up to this point, omitting this diode, if you look here, so this is your terminal, this is load, it will be. So up to here it comes to your VM, that means this is your half wave rectifier. Otherwise, if you omit this one, from negative half cycle, you can get this one, and this is your ground terminal. So you are getting the negative half cycle. So full wave rectifier is nothing but the combination of two half wave rectifiers. Simply one word, I am considering two diodes, placing on one in positive terminal and next one is negative terminal. The center tap will be acts as my ground potential. Here. Okay. So now, this is positive of my transformer. This is the negative of the transformer. Similarly, this is the cathode. This is anode, this is cathode. This is anode and this is cathode. This is diode 1 and diode 2. And load resistance RL. Okay. across which the voltage will be, because you are considering the current will be comes from this direction. Okay, so it will be positive. Okay, so here when positive half cycle is applied, when positive half cycle is applied, okay, when positive half cycle is applied, now we need to consider two diodes at diode D1. Diode D1, anode is positive, cathode is negative. Current flows from anode to cathode, and this is the circuit path. Whereas that means diode is short circuit, and that is on condition. You may consider either short circuit or on condition, no issue. Now at diode D2, this is negative terminal. That means even though you applied positive, it will be negative here. So this is negative, and your cathode will be zero potential. From lower potential to zero potential, current doesn't flows. It is an open circuit, is in off condition. It is off condition. Similarly, when I go for the line diagram, what will be the condition? This is short circuited, this is open circuited, but anyhow so positive peak directly fed to the load, and it has the closed path, and it will be closed. So the current will be have the closed path. So even at positive half cycle, diode D1 is conducting, diode D2 is in off condition, the current will be flows through your load resistance. That means at this condition, the current is flowing from this side to this side, okay, from positive to negative terminal, this will be your voltage across your load resistance, similar to your applied voltage. Now there is no issue. So this is the case when I apply positive terminal. This is the case how I can get. What about my negative terminal? What about when I apply the negative peak? Okay, so when I apply, no issue. So when I apply negative peak here, so this anode will be negative, cathode will be at zero potential. So this one is negative of negative, that means it is 180 degrees phase shift. The transformer is shifting here its properties by, that means when I apply the positive here, it is converting this one as negative. When I apply negative here, it is converting it to the positive. That is, it shifting by 180 degrees. So this is positive and this is zero potential. So automatically this is in off condition. In negative, at diode D1, anode is negative, cathode is zero, open circuit, off condition. Diode D2, anode is positive, cathode is zero potential, higher potential to lower potential, short circuit and on condition. So here kindly check the current path. So now it is an open circuit, so this is short circuit and this is the current. So the current flows from here, conducts okay. So whatever may be the, whether it is in positive peak or negative peak, the current direction doesn't varies. The current direction, whatever the voltage you are applying here, that is here all it will be converting into positive. It is converting into the positive. So you are getting output voltage across your diode is positive. So whatever may be the, whether you applied positive or negative half cycles, you are getting this peak. Then the question raised by you will be, when we can get this output waveform. So kindly, instead of this from positive to negative, if the current in your diode is from positive to negative, that means the current flow through your negative of your diode, it will be negative. Okay, if this is in a higher potential, I mean the negative terminal is higher potential, so you can get this one. So here it is positive, that's why you are getting this one. If you are getting the negative, this will be your output, expected output. So kindly check. If you have any doubt, kindly check through your CRO experiment. This is the operation of your Fourier rectifier. Thank you. I hope it will be understandable for you. Thank you.